Good? Well, okay. Ok. Malheureusement, je parle pas beaucoup de français, donc c'est en anglais. Heureusement, malheureusement, je sais pas. I'll be speaking to you about TypeScript, you, and AI search. If I go a bit too fast, let me know. I tend to do that sometimes. I'm Daniel Piri, also known as Valgamvis, anywhere online. I do developer experience at Weaviate. I'm a writer, developer, artist, plant dad, and a Lloyd Stan. So this talk is a multifaceted talk because doing developer relations, I sort of build a lot of things. And I've been building a lot of things with AI, as a lot of people have been building. And getting into a job I got to about a year ago, I was charged with fixing the developer experience of a TypeScript client, right? That would enable AI developers. And so I thought, why wouldn't we sort of craft this TypeScript client in a way that it takes advantage of a lot of the really interesting things about TypeScript, in how they work with the IDE that you use, VS Code, Cursor, or whatever, as well as sort of like teach you how to use the product. So we had sort of like two goals here. So yeah, we spent a lot of time working on this TypeScript library release. Good news, we're GA. We've been GA for about 6 months, so that's great. This is a good time to clap also if you want to. Thank you. So yeah, I think like it'll be a bit of a journey. So we'll talk about AI search, talk about TypeScript, and we'll talk about you. And I think we'll start with you, just sort of get an idea of what the usual search experience is. Like I mentioned, I work at Weaviate and we do a lot of search things. So I'll show you what a lot of people experience when they search. So we have an application here. So hello. This is usually you when you're looking for like, how do I search, right? A lot of times we do something like keyword search. And just to give you an idea of the data that we're searching over to start with, sorry about that. So we have this sort of data set, very easy, couple songs. We have an artist, we have a title. And usually when we want to search something, let's say we want to search like Ibiza, anything close to Ibiza, we would have to we'd have to know the keyword, right? We'd have to be like Ibiza. And then we search and we get that back, right? That's great. I think we're all used to searching like this, yes, right? However, let's look at something like good vibrations. And if I searched good vibes, so good vibrations, good, right? Good vibes, not good, right? Like it should be there somewhat, like if you want to sort of like present that to someone. And we have a lot of situations where we have things that seem kind of obvious, like good vibes, good vibrations, terrible example, but I think you get the idea. And so it just doesn't really work. And I just demoed why and how that works. And I think this is important to sort of start with you and search, because I feel like everything we do on the internet starts with search. When we're looking for music, when we're looking for films, when we're looking for like Wikipedia articles, for random things we're trying to fact check, we search, right? But the problem is search works, like I just showed you, sometimes, but also it leaves us feeling like this, right? We've got a response, but we're not necessarily happy with it. And it feels like everything is wrong. And the problem is a lot of the search we do is traditional search. And that usually is keyword matching. So when we search something like, why do airplanes fly? We get a response like fly with expensive airlines, which is essentially an ad. That's not what we want, right? But technically, if you look at like search and response, we searched for something, why airplanes fly. If we look at the way we're used to searching, right, we get that response and we'll say, oh yeah, it's valid, I guess, right? But it's not a really good user experience for your users, right? That's not what your users want. And no one wants that, you as a developer or your users who are using your app. And so I want to introduce this concept, and this will make a lot more sense when we get into the library that I'll be talking about of semantic search, which is it's a tool that understands the context of what you're searching over or your data that you're inputting. So when you use like a semantic search example and you search something like why do airplanes fly, you get an answer like dynamics of flight, right? So it understands the context of the question. Why do airplanes fly? You want to understand the mechanics and the science of that, and it sends you back this response, which I think is more useful than expensive airlines, right? And so at this point, I think like you'd be probably said, yes, I want to go for semantic search. Maybe let's get into how exactly this works, right? So this is the AI portion of the talk. It's machine learning algorithms. Specifically, I'll get into those. And so you see numbers on the right here. I think it's left for me, left, which are, it's an array of numbers, which we like to call vector embeddings. So you might have heard this term, vector embeddings. It's a representation of real world data, sort of an abstraction, so that computers can understand them better. And so we have algorithms that are made specifically called embedding algorithms to sort of abstract real world data, be it text, be it images, be it videos, into these embeddings so you can actually search over them. A practical example with the example that we're already familiar with is fly with expensive airlines. That's an article. We put that through our machine learning algorithm. We get these vector embeddings, which represent that data. We have the explanation from NASA also. We put those through our embedding model, and we get the vector embeddings. We then put those embeddings in a space. You can think of this space as a database, Postgres, and then we're able to now search over them. So what happens when we actually make this semantic search query is we get our query and we create vector embeddings for it also, right? We plot those embeddings into our vector space, into our database, and then we use sort of like approximate nearest neighbor search algorithms to look around and say what's beside me is probably familiar or similar because of the way this embedding algorithm works. And so we send back the most relevant items by distance. And this is like an oversimplification of how everything happens. But in this case, that nearest item happens to be the article from NASA. And so yes, essentially that's embeddings, that's search, that's how semantic search works. And because of this abstraction from like the original data type into these vector embeddings, what we can do is we can have multimodal embeddings, which means we can have multiple types of data types. So text, images, video, audio, and we can search over them as we would anything else. And yes, so essentially we'd replace a text encoder for the text that we put in for an image encoder, and then we have very similar functionality. And so like for anyone who's tried to work through images or video and search through that without using anything like the metadata, I think you would really appreciate how that works. And I have a really quick demo here before I get into the code of something that uses multimodal search. So I'm able to input some stuff like dogs, and it understands that dogs bark, and it sends that as a response. And it has understanding of what a dog looks like, and it puts that in a video. There's so many things that you could do with this. So yeah, search. Okay, yeah, all of that is powered by Weaviate. I mentioned at the beginning, I work for Weaviate, an AI native vector database, and that's the SDK that I was crafted to sort of put together. Who's heard of Weaviate? Nice. Okay, I have like custom stickers for you. You should ask me at the end. Anyway, so these are the clients that we support, and you can see over there we have TypeScript, and that's what this talk is about. So I'll just get quickly through like what a search workflow looks like. The quality of your search is mostly dependent on the data you put in, right? And so we have, in the example that I'll be giving next, a bunch of articles from Wikipedia, which I put through my application, and I send them to my vector database. My vector database, Weaviate in this case, sends those items. So I have about 10,000 Wikipedia articles that I send to my vector database. It creates these vector embeddings, which represent the sort of abstraction of these actual objects. And then those objects and those embeddings get sent back to my database, and they're stored in my database. That way, whenever I want to query them through an application, I can make a query, like how do planes fly? It looks through that data, and then it sends that data back. Right, okay. We have like an understanding. We have a bunch of different models that we support, OpenAI, Cohere, Hugging Face, Mistral AI, blah, blah, blah. Okay, So demo. We'll sort of build out this application. I think you sort of saw the beginning of this with the keyword search demo. The second part of this actually is, hello again, is the vector search. So this doesn't work. By the way, this is an application that's built with Nuxt.js. I don't know if we've got any Nuxt.js fans here. I'm a big fan. And I'm also a big fan of Nuxt.js's TypeScript support. So, okay, we'll go into VS Code now. I'll just rearrange this so it makes some sense. Okay, we'll go into VS Code, and the first thing that we want to do is sort of give you an understanding of the interaction between the different parts of this application. If you're not familiar with Nuxt.js, we sort of have pages here that act as where we put our template. Vue usually follows this single file component paradigm, where if we look in vector, we can add our templates, HTML, we can add our scripts, JavaScript, and we can add styling in CSS. I'm using Tailwind for styling, so I'm not using any of that. So this is everything that you see here, vector search with Weaviate. And the interesting part really is here in the script section. I'm already using like the TS option here for my script language and script setup, and I have and can import a couple of types. So if we look in my types.ts file, I have a couple collections, so Wikipedia collection, and basically I sort of described my data as having the title of a Wikipedia article, a description of the Wikipedia article, and the URL to that Wikipedia article. And then I do some other things with like a specific type for a generative search result and a type for like a search result. And so this is sort of like the first look at how we thought about sort of the developer experience of this TypeScript library. We're using these really cool generics where we have this Wikipedia collection and we sort of put that into the generative object, which you could see when we investigate here, is sort of a type that represents the result of our generative search. And similarly, a Weaviate object also represents what the standard shape of a Weaviate object looks like, with the ability here to have your generics that you define for your own specific data. And so that's already something that we thought about, which I really like. Okay, so that's the template side. We also have an API route here. If you're unfamiliar with using Next.js, you have an API route where you can create different APIs. I have a search API here that I've built, a search route for my API. And in that, this is where we run our vector search. And so, right, we'll do like the whole path from here. We're in the front end, back to the API where we make the actual search, and then back to the front end where we display everything. So really quickly, we have these types. We're not using them yet. We have a submit search function, which basically when we click search, we make a search, get a response. And then this calls API/search, and then we have a query parameter of search term, which we input. So let's go into search, and then really quickly get into what we're doing here. So we're using the Weaviate client, like I mentioned. We're also using Zod for validation. I like how, and I'll probably talk about this at the end. There's a whole talk around sort of like having that validation on the front end, back end, and connecting them together so that your type safety at the back is your type safety at the front, and you only have to do it once. So anyway, we're using Zod for schema validation. We're making a query, so we're checking that the query is valid and matches the schema that we're expecting. And then we have an event handler here, where after validating that query, we pass that and then assign the search term as what we got in our query, and then make that vector search here. So currently, vector search is empty, right? And the idea of this talk is sort of like to put you through the experience of someone who's new to Weaviate, because a lot of people are new to this concept of AI search, generative search in general. And so we wanted to craft that and make it as easy as possible when you have like these core concepts of how you can do this. So the first thing usually when you want to work with a database is you think, okay, what database am I working with, right? If it's Postgres, you're like, okay, Postgres. I'm working with Postgres. What table in Postgres am I working in? You choose your table, then you choose your column, then you choose your data that you want, right? And so essentially, it's the same idea with Weaviate. We start by defining sort of a variable to describe the collection, which you could think about as a table in Weaviate. And so this is a wiki collection. So const wiki collection is equal to client misspelled. So client dot, and so now this is what I was talking about. We have all these really we're making use of the intelligence that the IDE gives us, and so we can make use of that. So we want to define a collection table. Once you're like up to speed with that fact that a collection is a table, you know, and you want to get a specific collection. My collection name is Wikipedia. And that's great. And then we can see here already that we have the option to pass in a generic to describe what that Wikipedia collection looks like, right? We'll leave that as it is for now, and then just keep on going and making the query. We have our collection. We want to sort of make a query, right? We'll just define response and have that be, what is that? So we use our wiki collection because that's where we're getting everything from. And we're making a query. And in that query, we're making a near text. And in that near text, you could see everything that you need to actually add. And I think this is something that we've got from a lot of people being unfamiliar with this. And that's something, like I mentioned at the beginning, we wanted people to be able to do this. So, okay, I have Wikipedia articles. I won't hard code this, of course, because we have the search term that we're passing in here. And so that would be our first parameter. And then here we can see we have other options that we can define. We, like in a traditional database, you can limit how many results you get. We'll stick this, we'll keep this as 5. And you also have the option to return metadata. And I think this is another really cool thing that you could do, because you're not really sure what type of metadata you want to return. But that sort of like hinting really, really helps. So because I talked about distance and what that is, we can return the distance. And then let's return response. And so because it already knows that, you might be asking, right, okay, what is the shape of response? What does that look like? And again, this is one of the things that we wanted people to be able to do in terms of like when we're thinking about what that developer experience is, hey, I want to be able to know what my data is like. Because we know that this is a Weaviate object, you can see this is a Weaviate return of undefined because we haven't set those generics yet. We know that we're at least expecting some objects. And I did talk about having those generics. I didn't import that. So I'll import the type that I have that we saw. What was that? Wiki collection, right? And then we'll pass this one here, wiki collection. And then here we'd be able to say, okay, what does this look like? We can get our properties, we can get our title, and it just makes that developer experience much, much easier when you want to do stuff with what you're working with. Right, anyway, we'll leave this as it is. And in what looks like, about 8 lines of code, we have this very powerful AI-powered search. And so I did not make any changes here. I will just go ahead and search Wikipedia. Anyone feeling confident to shout something I should search for? No problem if not. Let's search for TypeScript, yeah. So remember I said your search is only as good as the data you put in. I only have 10,000. Oh, there we go. 10,000 items, right? So a great example of, just to like show how this works, is typed JavaScript, right? I don't know if this will work, but let's see. There we go. And we can see the most relevant at the top is JavaScript, right? I'll zoom in just so it's visible. Sorry? It could be, but that's more of a distance thing. If that's the most relevant, that's what it will send back. But also because conceptually, TypeScript and types JavaScript are the same thing, right? So that's sort of like that understanding that has. And also, the thing with AI search is it goes as far as AI models go. One thing I did with this is I used Cohere's multilingual embeddings. And so what that is I create these abstractions of data in multiple languages. And so I can search like piscine, which is swimming pool, right? And so I get that because there's that understanding. And I can search like something more specific. Qui gagnait le Coupe du Monde? Well, close enough, but there's an understanding of this search query in another language, right? Let's see. Anyone speak another language? No worries if not. Okay, so basically, this is how we were thinking about putting this together, and this is one aspect of AI search. This is talking about the search functionality. We can also take this a step further and look at RAG, something called retrieve augmented generation. Anyone familiar with what retrieve augmented generation is? Okay, you might be a bit more familiar at the end of this talk. So if you've used something like ChatGPT or I think Mistral because France and what else? What else do people use? The popular one now is like Claude, Anthropic, right? It like these large language models have a problem with making things up, and so retrieval augmented generation is a concept that gives these large language models context into what you want them to answer. So if I ask, when was I born? I asked ChatGPT when I was born. It has no idea, but it would make something up. But essentially, I could sort of get all my birth information, my name, when I was born, the city I was born in, give that to ChatGPT and say, hey, based off this data, when was I born? And then it gives me an actual answer. And so that's the idea of retrieval augmented generation. And we'll be able to do that with Weavit also. And so I'll follow a lot of the steps that I followed with making the previous one. So we define our collection. So Wikipedia collection is equal to client.collection.get Wikipedia. I should have pasted this. Okay, and then the response is Wikipedia collection, and then I want to make a generative query because I want to use generative search. So I use generate, and with generate I can use near text, which means text is the input. I pass in my search term, and this is where it gets a little more, a little more complicated actually, but not too much. So, yes, wrong format. Okay, so first term, search term. Second term is your prompt. What are you sending to the large language model? And so we'll go with what we call a grouped prompt or a grouped task. And so this group task basically takes all the search results that you have and then sends those to the large language model with a prompt. And so I'll say, pretend you are a primary school teacher and explain search term to me in explain the answer, because we're going to ask a question, right? So explain the answer to search term to me in the most basic English, and a French translation at the end, right? Translation. Okay, so that's something that you could say. And then you return your response. Oop. Right, return response. And again, we could do that thing where we pass in our generics, but I think I don't really have a lot of time. And we've seen that already. I'll just go really quickly to our RAG and see how we're presenting our data. And so we're getting our data back. And we're displaying this as, where is this? What are we using? Search result and then generate. Okay, so we can just send back our response as it is. And I'll save this. Let's look at it. We can also group these actually, just so I can show you what the other thing is really quickly. We could use a single prompt. So what a single prompt does, it takes each response that we get from the vector database and it passes that to the large language model. So translate this to Italian. Okay, translate this. But we need to specify what this is. We want the title. And we know that we're getting title because our type here is title. And we do some really clever engineering in the background to sort of parse this string and then sort of interpolate that as we send that response. Okay, we also want to limit, we don't want to get all the data from the database. So we'll add again our limit of like 5 items, save, and we need to change this URL to rag. And so I'll search something like sports done in the winter. Let's like Olympic fever, so Olympic sports. Olympic. Can't spell. Okay. Let's see what we get. It takes some time because it talks to the large language model and there's some latency there and then it has to send something back. Let's see. Yeah, just need to make sure also that like nothing went wrong because. Okay, yeah, I think it's an internet thing. Oh. Network. Yeah, so it's let's wait. We should be patient. Yeah, maybe because also I'm streaming to the thing, so there's some. Okay, failed. Yeah, we have a timeout. Right. Okay. To fix this, I have to recreate the collection because you have to set the timeout per collection. And I don't think I have the time to do that. But maybe let's make this smaller and take away the single prompt, just so we could try that. Oh, what are we looking for? Hopefully it works.
Most simple, like because there is the several term that be confusing for the.
That's true. It could be. Let me just look at what's happening here. Yeah, I think it's mostly just Where
did you expect the response to you?
So the response is the results that we get from the search. So you get the research results, and then you have a lot of text that you get also. It could be.
Internet we have.
Possibly. Okay, I will. Do I have some time? 5, 10, 3, 2?
Not so much.
Okay. Let. Okay, I'm almost done. I have another sort of application that I haven't shared with anyone. No time to make a demo, but
No, for the question,
Oh,
to
yes.
make a demo on what the primary teacher that explain how to make a demo. Maybe that's the time to explain.
maybe we'll try that after we try this. So this is another application that I have, sort of like a hiking application. You have a bunch of trails, so you can describe what type of trails you want to go on, right? So I want to go on a hike, a nice sunny hike. So it's the same concept. Let's see. Okay, there we go. Finally worked. So we get this hike with the location, data. So what it does is it searches through a bunch of different hikes that you have, um, and then it sends them to the large language model, and then the large language model, based off what you asked, decides what the best hike is. And then, really interesting, you also get these product recommendations, because this is an e-commerce demo. And because it understands that this is a sunny hike, it's like, get some sunglasses, get some water, get a hat. Um, Very expensive hat. It's designer. But as you can see, this is a demo that is, it is not 100%. You can see I haven't fixed everything. But anyway, that's the concept. And I hope this helped sort of like share the journey that we went through, like thinking about how we want people to use um, this library, thinking about how TypeScript can help us, one, make the development easy, but also make the experience of learning more about the technology and the tools a bit easier. We just released something. I do not have a link uh, because it was literally just released before I got here. We have an academy that you could go through if you want to learn more about any of these things, if they're interesting to you. There's a QR code, also with a bunch of resources that you can check out. And again, thank you for your patience. If you have any feedback, catch me later, and I have a bunch of stickers if you need some. Thank you.